So today we are talking about the ECG. ECG is the graphical recording of the electrical activities of the heart, which are generated the each during each cardiac cycle or each heartbeat, and graphical record of that is the ECG, electrocardiogram. The instrument we use to record the graphical activity is called the electrocardiograph, and the procedure for recording ECG is electrocardiography. So electrocardiogram is the record, electrocardiograph is the machine, and electrocardiography is the procedure of recording the ECG. So this topic we will discuss in three aspects. One is the what are the methods to record the ECG. Second is actual record, how we can interpret, and third is the applied of the ECG. So in this we see it the electrodes has been placed. Depending upon the electrode has been placed, we have the combinations. So the combination of two electrodes has been called the leads. So in the ECG recording, we use the limb leads, okay, bipolar leads and unipolar leads. Bipolar leads means that both the two electrodes are the active electrodes. So that is called the bipolar. In unipolar, the only one electrode is active electrode, another is electrode is kept is indifferent electrode. Another electrode is indifferent electrode or inactive electrode. Okay, so it is a 12 lead ECG recording. In this, you have the three bipolar limb leads, then three unipolar limb leads, that is augmented unipolar, and six unipolar chase leads. So three bipolar limb leads, three unipolar limb leads, and six augmented chase leads. So six chase leads. So three plus six is 12 lead ECG record. So lead one is the combination. Lead one is the combination where the negative electrode is connected to the right arm of the ECG, positive electrode is connected to the left arm of the ECG. Lead 2 is where the negative electrode is connected to the right arm of the subject, positive electrode is connected to the left leg, and lead 3 is where negative electrode is connected to the left arm and positive electrode is connected to the left leg. So in lead 1, negative electrode is connected to the right arm, positive electrode is connected to the left arm. In lead 2, negative electrode is connected to the right arm, positive electrode is connected to the left leg. And in lead 3, negative electrode is connected to the left arm and positive electrode is connected to the left leg. So lead 1, lead 2, lead 3. These are the bipolar limb leads. So that we already discussed these bipolar regarding bipolar limb leads, lead 1, lead 2, lead 3. So lead 1 where one electrode is connected to the right arm, another is connected to the left arm. The electrode which is connected to the right arm, which is attached to the negative terminal of the ECG machine, electrode connected to the left arm, which is attached to the positive terminal of the ECG machine. Lead to one electrode is connected to the right arm, another is connected to the left foot. The right arm is connected to the negative terminal of the ECG machine, and left arm is connected to the positive terminal of the ECG machine. Lead 3, the one electrode is connected to the left arm, another is connected to the left leg. The uh, uh, left arm is connected to the negative terminal of the ECG machine, and left leg is connected to the positive terminal of the ECG machine. Now, the concept of influence triangle with the if the a triangle has been drawn on the chest with the heart at its center, so we can draw an equilateral triangle. The 2 points corresponds to the right and left acromion processes, and the third point is the pubic symphysis. So if you join all these 3 points, a triangle can be drawn over the body, okay, with current source, that is the heart at the center of this triangle. And this triangle has been called the influence triangle. You see this in diagram, the influence triangle, heart at its center, and the equilateral triangle. Lead 1 extend from the right to the left arm. Lead 2 extend from the right arm to the left foot. Lead 3 extends from the left arm to the left foot. Left arm to the left foot. Okay. Lead 1 extends from the right arm to the left arm. Lead 2 extends from the right arm to the left foot. Lead 3 extends from the left arm to the left foot. Lead 1 compare the right foreleg with the left foreleg. Lead 1 compare the right foreleg with the left foreleg. Lead 2 compares the right foreleg with the left hind leg. Lead 2 compares the right foreleg with the left hind leg. Lead 3 compares the left foreleg with the left hind leg. Lead 3 compares the left foreleg with the left hind leg. And one extra electrode is attached to the right hind leg for the earth. So when you draw the influence triangle, the potential, the sum of the potential at the corner of the equilateral triangle is equal to the zero. That is the influence law. The sum of potential at the corner of equilateral triangle is equal to zero. That is the influence law. Or in short, the potential of a lead 2 is equal to potential of lead 1 plus potential of the lead 3. So influence triangle, influence law, if the electrical potential of any two of the three bipolar electrographic leads are known at a given instant, the third one can be determined mathematically by simply summing the first two. Okay. So if you know the potential of any two bipolar leads, the third one can be determined mathematically by simply summing the first two. This is one, or in short, the potential of a potential at an equilateral triangle, the potential at the lead 2 is equal to potential at lead 1 plus potential at the lead 3. Now, uh, this is the limb leads. Then you have the unipolar leads. Unipolar leads, you have uh, in unipolar leads. What is the thing is that the uh, active electrode is placed on one limb, and rest of the three electrodes are connected through a high voltage resistance, that is a 5000 ohms resistance, and connected to the negative terminal of the ECG machine, and potential of that electrode is the zero potential. So if we place the active electrode over the right arm, then that combination is called VR. If you place the active electrode to the left arm, that combination is called VR. And if you place the active electrode to the left foot, that combination is called VF. So you are VR, VL, VF. These are the three combinations. So in the the unipolar limb leads, basically there is only one active electrode, and depending upon you place the active electrode on which limb, you label as VR, VL, VF, and the another three limbs are connected through a high voltage resistance and to the negative terminal. Potential of which has been kept with the zero potential. Now, but the record we obtained by this is quite a very smaller size record. So, if in order to amplify the potential, in order to get magnified record, we use something called augmentation. So, there is a augmented unipolar limb leads. In augmented limb leads, instead of placing all the three limbs uh, through a high voltage resistance, only two limbs has been placed through a high voltage resistance. The limb on which active electrode is kept, that limb has been uh, disconnected from the combination of the three limbs. Means suppose we are placing active electrode on the right arm, so the another two limbs, that is left arm and left foot, has been placed through a voltage resistance, and their potential has been kept at the zero potential. So by doing this combination, the potential obtained is 50% or 50% more than the uh, non-augmented limits. So this is called the augmented limit. So you have, as you have the unipolar leads 3 VR, VL, VF, augmented leads AVR, AVL, AVF. Now you have unipolar chest leads. So in unipolar chest leads, obviously this is the unipolar chest lead. So all the three limbs is connected through a high voltage resistance and kept their potential has been zero potential. And the active electrode you place where, so depending upon active electrode you place where, the uh, you have been labeled V1 to V6. So V1, the active electrode, this is called the chest leads because the electrode has been placed over the chest. So you have been called V1, where the active electrode has been placed into the fourth intercostal space right parasternally. You have been called V2, where the active electrode is placed fourth intercostal space left to the parasternally. V4, where the active electrode is kept into the fifth intercostal space uh, at the mid clavicular line. V3, active electrode is kept between V2 and V4, and V6, active electrode is placed into the V5, where the active electrode is kept at the anterior axial line into the fifth intercostal space. V6, active electrode is sorry, V6, where active electrode is kept into the fifth intercostal space into the mid clavicular line. So can I repeat it? V1 where active electrode is kept into the fourth intercostal space right parasternally. V2 where active electrode is kept into the fourth intercostal space left parasternally. V4 where active electrode is kept into the fifth intercostal space at the mid clavicular line. V3 is between V2 and V4. V5 where active electrode is kept at the fifth intercostal space in the anterior axial line, and V6 where active electrode is kept into the fifth intercostal space is the mid axial line. So normally V4, V5, V6 has been kept at the same line irrespective of the intercostal space. Okay. Now this how you can find out the intercostal space. That is the first you can place your finger over the sternal notch, palpate over the mandible, go down where you feel the bridge roughened surface. That is the point. That is the sternal angle or angle of Lewis. So that corresponds to the second intercostal space. Count the intercostal space, go down, and you can find out the fourth intercostal space. There is one way or another way. Roughly, the level of nipple is at the fourth intercostal space. Okay, level of nipple is at the fourth intercostal space. So uh, below, accordingly, you can count the intercostal spaces. So V1 view the heart from the interventricular septum V1 and V2. So they can tell you what are the changes happening on the interventricular septum. V3 is the V3 and V4 at the surface of the heart. V5 and V6 lateral surface of the heart. So if you see how the leads has been placed and oriented towards the heart, so this is the position where lead 1 is directed at the 0 degrees angle to the heart. Okay, lead 2 60 degrees of angle. Okay, lead 3 at 120 degrees of angle. AVL minus 30 degrees of the angle, AVR minus 155 degrees of angle, and AVF plus 90 degrees of angle. Okay, so if you see that lead 1 is at the 0 degrees of angle, everything below is considered as the positive, everything above is considered as the negative. Okay, so lead 1 0 degrees of angle, lead 2 is plus 60 degrees of angle, lead 3 plus 120 degrees of angle, then AVL minus 30 degrees of angle, AVR minus 150 degrees of angle, AVF plus 90 degrees of angle. So if you see it, AVL and lead 1 record the electrical activities from the left lateral surface of the heart. Lead 2, lead 3 and AVF records the electrical activity from the inferior surface of the heart. And AVR records the electrical activity from the cavity of the heart. So basically, this diagram is trying to showing how the uh, from the influence triangle, how these leads we make the arrangement, okay, so that the all the leads passes through a common central point. So okay, so if you just rearrange this influence triangle, so borders of the influence triangle, if you make the rearrangement, so that the they pass through a common central point. Now if we make this arrangement, then the position of the leads is lead 1 is a 0 degrees angle, to lead 1 at 60 degrees angle there is a lead 2, and at 120 degrees angle is a lead 3. So this lead 1 at 0 degrees angle, lead 2 is plus 60 degrees of angle, lead 3 as plus 120 degrees of angle, AVR is minus 30 degrees of angle, AVR is AVR is minus 150 degrees of angle. Okay, then AVF is plus 90 degrees. So which leads look where? Okay, so inferior wall lead 2, lead 3 AVF, septum intervertebral septum lead V1, V2, anterior wall V3, V4, lateral wall 1 AVL and V5, V6. And anterior wall and septum often infer together because both are supplied by left anterior resisting. So anteroseptal myocardial function shows in V1 to V4. So that is they are showing normally changes between septum and anterior wall cannot be separated because both are supplied by the left anterior descending artery and by V1 to V6. V1 to V4. So with this recording we stop, and in the next lecture we see the what is the normal interpretation of the ECG.